Hello and welcome to week 7. I'm recording this on June 28th, Wednesday. And as you can see from the banner, we're studying uh, physics of the nucleus. And I have some examples of important nuclear reactions that convert one element to another element. For example, this is beta decay on the far left. It's faint, so you can look it up in your book. But that's where an electron is emitted. And that's from and a neutrino, and that's from the disintegration of a neutron. So the neutron becomes a proton. So that increases the charge of the nucleus by 1, moving it up the periodic table to the next family on the periodic table. Here we have alpha decay. That's where the nucleus of a helium atom uh, is ejected from the nucleus. And that will drop it down by, that takes 2 protons away. So that drops it down by 2 families on the periodic table. And we have, it's kind of cut off here, but that's beta plus decay. That's where a positive electron, also known as a positron, is emitted due to the conversion of a proton to a neutron. So a proton becomes a neutron. That increases the number of neutrons by 1. And the proton, you lose 1 proton, and that means it drops down 1 on the periodic table. There's a whole host of other reactions, but those are 3 of the most common ones. And here on the left, kind of a shadow is an image of Maria Goeppert Mayer, and she won the Nobel Prize for introducing the shell model of the nucleus. And that explains the stability of certain nuclei. Why is it that a nucleus with so many neutrons is stable, and then you add another neutron or subtract a neutron, and you might have an unstable nucleus that, then that element is, you have a radioactive isotope. So she explained that with her mom, got a Nobel Prize for that. And then Enrico Fermi is one of the great physicists of the 20th century. He described the statistics of particles with non-integral spins, like the electron. Those are called fermions. So electrons, muons, a whole host of other particles that have spins that aren't like 0 or 1 or 2, but fractional spins, plus 1/2, minus 1/2, 3/2, negative 3/2, etc. Those are called fermions, and they follow a whole different set of rules called fermion statistics, as opposed to bosons. Classic one is the photon, has a spin of 0, and you can crowd as many photons into a space as you want, whereas no 2 electrons can have the same set of quantum numbers. Okay. And he was also the head of the effort at the University of Chicago during the Manhattan Project to have the first sustained fission reaction. So the first nuclear reactor was built under his leadership. Okay, so he was great. Both of these were great figures in history of modern physics. Okay, getting to this week's module. Usual things here, interactive overview. Try to get that done by Thursday. That would be June 29th. And it only takes about a minute. I try to look at those as soon as I can. The discussion topic, you're supposed to respond by midnight on Thursday. Again, that would be midnight Phoenix time, Thursday, June 29th. So if you don't get it in by then, I'll probably send you a note reminding you, and you'll lose some points because of that. Okay, it's important to do these on time to give your classmates a chance to respond to them, to read and respond to them. All right, reading review quiz. Well, that's up to you to take anytime between now and Monday. I do I've scheduled a live meeting, and I usually give example problems that I've chosen especially to be helpful for that quiz. So, I also encourage you, if you cannot attend the meeting, at least watch the recording of the live meeting. And this is in some ways the easy part or the difficult part. You do the simulation. Most people, I think, enjoy those. And then you write a lab report on that. So lab reports have been getting better. So let's make this last one great. And I've already graded all the submissions for the week 6 lab reports. So if you complete a lab report, you should see your score in the grade book. If you haven't submitted your lab report, please do so. I've sent out reminders about that as well. Okay, so again, the live meeting is on Friday at 5 p.m. Phoenix time. Just click on the link, and it'll tell you what it is in your time zone. So that would be 8 p.m. in Eastern time, and whatever time zone you're in, it'll tell you the appropriate time. Okay, I've made this even longer than I wanted to, so that's all for now, and I'll see you in class.